Oh, Jules.
Hello. So, what are we doing now? We're having a lot of fun here. Making these cables. So these are the cables for our battery management system. And the battery packs, you'll see have got little connections on them. And the BMS unit will be talking to a column here of batteries, and will balance across that column of batteries, which is what this pack is designed to do. The actual individual batteries are running in series in our rows here, so it's a bit different to a normal lithium iron phosphate pack that you'd put together and you've already got your cells made up. So we've got the cable here, we're crimping on these little connectors in the middle of this cable, which is rather time consuming and boring. What tools have we got for the job here, Jace? Cable, crimps,
Crimpers.
the crimper itself, and yeah, pliers to cut the cables, more pliers just in case. There are two primary jobs for a BMS. The first is to monitor your cells and do something if they go out of range. The second is to balance your cells. So if one cell is higher than the other, you can drain that, usually at the top of the charge, or take some other action. Well, let's have a look at a really simple example of why you might need a BMS. Here we've got 4 cells in a battery. It's a 12-volt battery, and each cell is 3 volts. If one of the cells were to be imbalanced, you can see the overall battery pack is still 12 volts, but we've got one cell that's dangerously high. Now, if you need to charge this battery to 13 volts to charge it fully, that's going to add charge to an already overloaded cell, and it could cause damage or fire. So you can see you need a BMS to measure the individual cells, otherwise you just have no idea what voltage the individual cells are. Let's have a look at the different situations our battery can be in. So we can start with the whole battery voltage being too high. Now this will happen when we're charging and we get to the top of the charge. In that case we want to stop charging. The responsibility for that is our 2 chargers. We've got an MPPT charger which handles the solar side of things, and we've got the inverter charger which handles the shore power charging. The whole battery voltage being too low, now this will be caused of course by loads on the battery. In that case we want to stop those loads, and we've got 2 loads. There's the AC loads, which is run through the inverter charger. Now this will automatically disconnect the inverter and turn off the inverter if the voltage gets too low. The DC loads on the other hand are connected directly to the battery, so we need some way of disconnecting those loads. And we'll be using the Victron battery monitor most likely to monitor the battery voltage and do something about it. Next up, we're measuring the individual cell packs with our battery management system. Now, in the case of the cell voltage getting too high, this would only occur if for some reason our chargers didn't stop charging, or if there's an imbalance with our cells, one of the cells might be too high, and thus the BMS will pick that up and stop the charging before it hurts anything. Now in our situation, we're probably just going to disconnect the battery completely if we reach this situation. And same with the cells getting too low. Again, if we're stopping the loads when the voltage of the whole battery gets too low, we should never encounter this situation unless there's an imbalance issue or for some reason the loads don't stop. So the battery management system will handle those situations. And it also handles temperature getting too high on the battery, and again we'll probably disconnect the whole battery. Alright, let's have a look at the BMS unit we're using. So this is a system from Ziva in Australia. Let's just run through all the components of it, what it looks like. Here are the 3 components we'll be using. We've got the EVMS light there in the middle, that's kind of the brains of the operation and where we connect everything to. Takes the power in, and we also connect a shunt to that. On the right we've got the 12 cell lithium BMS module. Now this is what actually is connected to the battery cells, and you might have more than one of them if you want to monitor more than 12 cells, and they're connected together to the EVMS light through a CAN bus. On the left you've got an optional screen, which we do have in our system, and that's used to configure the BMS and also just monitor the state of all the cells and the overall voltage. So this is how we're planning to wire up the BMS into our battery system. So you'll see we've got in the middle there our EVMS Lite version 2. Connected to that is the lithium module, and you'll see that's got the individual strings running from it to monitor the cells of our battery. And you'll see connected to the CAN bus there is the Ziva display as well. So to recap, when something goes wrong with the BMS, like for example we have cell voltages out of whack, we want to disconnect the battery. So to do that we're going to use the Victron Energy Battery Protect. So the Battery Protect there is basically going to be used as a switch to disable the battery if anything goes wrong. We've got a shunt there which is monitoring the overall battery voltage, and we've got the circuit breaker, which is our main switch to turn on and off the battery, as well as basically it acts like a fuse. So the beauty of this is it means the whole system is pretty self-contained. We can install all this equipment inside the battery box. So if we disconnect the battery from the rest of the van, the BMS will keep working and we'll be able to disconnect the battery. Now our battery voltage is 29 volts throughout the system there. The Ziva works at a 12 volt level. So to power the BMS, we're actually using a little buck converter, which will take that 29 volt power and convert it to 12 volt power. You'll also notice the BMS control to the Battery Protect is 12 volts, and we've tested this and it works quite happily to control the Battery Protect, even though we have 29 volts going through the Battery Protect. Well, we decided to mount all the electronics on this piece of polycarbonate. Partly so it looks cool, but partly so we can easily see how it's wired, and if we want to show people what it looks like, we can show them easily. Screwed everything into the polycarbonate, drilled some holes where we wanted all the cables to go through. Here we are deburring the holes so that the cables don't rub on them, on the sharp edges. We're pretty happy with how it came out. This is wiring up the buck converter. So we'd solder the cables onto that. Then we just sort of weaved the cables through, and the nice thing about this is it also holds all the cables in place neatly. Next up we made some battery cables, and we're actually doing double cables off the bus bars here, so of equal length. So the advantage of doing that is then we end up with more flexible, smaller cables and more even draw off the batteries. Of course, heat shrink the ends of them. We're using blue cable, so we used the correct colour heat shrink on the ends of them to identify positive and negative. Alright, we've just installed our bus bars. So we had Jason machine these out, and we've just had them gold plated, because why not? We had access to gold plating at a very affordable price, so that will just protect the copper and make sure it doesn't corrode. Those aren't the correct bolts yet, so we need to order some more. Here we are plugging in all the BMS cables. So it's quite important to do these, plug in the other ends first so that we don't have live cables dangling around. Alright, I'll just explain what we're doing. So we've got here the voltage regulator buck converter, which has got a variable control on it to control what the output voltage is. The input voltage is
29 volts at the moment, I think it was.
29 volts, and we want to output 13 volts. So we'll just demonstrate what it looks like when we tweak this. So it's got a little screw on the top. You can see it's 13 volts at the moment. And if we turn this around to the right, voltage goes up. It's 15, 16 volts, for example. And we want 13 volts, so we're just winding it down to 13 volts. So this will output up to 2 amps of power. So our BMS here will only use a few hundred milliamps. So this buck converter will be perfect. Alright, this is the moment we've been waiting for. We've connected all the BMS. All the BMS cables are done, connected. And the next step is to plug that into the power at the end there. And then we'll be able to test the BMS system. Hopefully we get some stuff pop up on the screen. Jason's reading the instructions one last time. What do the instructions say, Jace?
Well, there's a lot of words, I didn't read them all, so
Yeah.
we'll find out later. Fell out.
Well, we had success there for like a second.
That does not fit in there.
Alright. We've got a low cell warning, but it's not surprising because it probably isn't configured yet.
Oh, look at that.
Alright. 28.9 volts. 3.6 volts per cell.
That's the maximum.
Oh, maximum.
Yep.
Beauty.
And we've got
Got a little flashing light on this part. We've got a blue light on here. And now we're going to read the instructions. Alright, we've just disconnected the key in, which then lets us configure the software here.
You don't like this beeping?
No, that's fine.
240? No, it would be more than that.
So one of the last things we did here was tidy up the cable somewhat, try and make it look pretty. Easily said, but hard to do. Alright, so that's basically where we got to at this stage. We discovered a little problem with the battery management system in that the configuration being set on the screen there wasn't being set to the bit that actually manages the batteries, which means it was trying to balance the batteries far earlier than they should be, and thus we had to send it all back to Australia to get the firmware updated on all of them, because apparently there was some sort of bug that was a known issue. So a bit of a pain, but once the BMS gets back, we are ready to install it in the van and plug it into the Victron. So we'll have another video coming soon that will show the whole thing working. And we'll give a little review of the battery management system once we know how it's actually performing. We'll also have a look at the Victron Battery Protect, which is a cool little device, and I need to order another one so we can disconnect DC loads. So heaps to come. Can't wait to get it in the van, plugged into the inverter and everything, so we can actually start powering stuff in the van. And then once it's in the van, we can get the solar panels on the roof as well, because there's not much point putting the panels on until the battery's in. So stay tuned, more coming soon.